Let's keep going with the chain rule, this time as it applies to trig functions. Let's start with some simple examples. Y equals sine of 2x. Remember, the chain rule is all about differentiating a composite function, a function inside another function. So what are the outer and inner functions? The outer function here is sine, and the inner function is 2x. Start by taking the derivative of the outer function. The derivative of sine is cosine. Leave the inner function alone. Then we multiply by the derivative of the inside. The derivative of 2x is simply 2. Move the constant to the front to clean this up. Pause the video and try the next one. Y equals cosine of x minus 1. Here the outside function is cosine, and the inside function is x minus 1. The derivative of cosine is negative sine. Remember to leave the inside alone. Multiply that by the derivative of the inside function, which is 1. Here's another one. By the way, the convention regarding parentheses and trig functions is that tan 3x is written to mean tangent of 3x. So it might help to add parentheses when differentiating arguments of trig functions. The outside function is tangent, and the inside function is 3x. So y prime equals the derivative of tangent is secant squared. Leave the inside alone. Multiply that by the derivative of the inside function, which is 3. For the following examples, pay attention to the implicit and explicit parentheses. Y equals cosine of 3x squared. This means we're taking the cosine of the quantity 3x squared. The exponent is only attached to the x. So what's the outside function? The outside function is cosine, and the derivative of cosine is negative sine. Remember to leave the inside function alone. Then multiply all that by the derivative of the inside function. The derivative of 3x squared is 6x. See if you can avoid the trap in our next example. If you haven't, pause your video and make your mistakes now when it doesn't count. So did you try using the chain rule or the product rule? Here, cosine 3 is not a function of x. It's simply a constant. So y prime is the constant multiplied by the derivative of x squared. The derivative of x squared is 2x. This one looks similar to our first example. The exponent here applies to the 3x, all before the cosine is taken. We can rewrite this as cosine of 9x squared. Now apply the chain rule. The derivative of cosine is negative sine. Again, leave the inside alone, then multiply by the derivative of the inside, which is 18x. Bring that guy to the front. And there's y prime. Pause the video and try this one. In this notation, the exponent is on the cosine function. That's the same thing as cosine x, that entire function squared. This makes the power rule our outside function, something squared. Bring the exponent down, leave the inside alone, and reduce the exponent by 1. Now multiply by the derivative of the inside function. The derivative of cosine is negative sine. Let's bring this negative out to the front. And there's our answer. Apply the same logic to this next example. When you have a radical, you want to rewrite in exponential form. Now what's the outside function? The outside function is something raised to the 1/2 power. So follow the power rule. Bring the exponent down, leave the inside alone, reduce the exponent by 1. Multiply that by the derivative of the inside function. The derivative of cosine is negative sine. Let's move this guy downstairs and rewrite him in radical form. Here are the 5 examples we just did, written side by side. Always read these rules from the outside in to identify what rule you're going to use first. Finally, let's try a problem where you have to apply the chain rule multiple times. Here we have f of t equals sine cubed of 4t. Let's rewrite this using parentheses. Now it's easier to see the 3 layers we need to differentiate. This exponent applies to the entire sine function. So let's start there with the power rule. Bring the 3 down, leave the inside alone, and reduce the exponent by 1. We need to multiply that by the derivative of the next layer, which is another composite function. So we need to apply the chain rule a second time. This time, the sine function is the outside function, and 4t is the inside function. So take the derivative of sine, which is cosine, leaving its inner function alone, and then finally multiply by the derivative of that inner function. The derivative of 4t is just 4. We can simplify this by multiplying the constants and reverting back to standard trig notation.